would, they just amplify different signals than what we would normally listen to. And I know they don't talk about it here, but I'm going to bring up, along with the, back on the air pollution and light pollution, wireless devices give off radio frequency radiation. So there's a problem with that kind of pollution too. I know they don't actually cover that in this, but just so you know.
They give off radio waves. The phones do. Okay.
And that's another form of, like I said, that's another form of pollution, because when you're trying to study, say a pulsar, which gives off radio frequencies, if somebody's got a cell phone near that just happens to be using the same frequency that pulsar is putting out, you may not ever know the pulsar is there, because somebody's talking to grandma or ordering takeout. I mean, it's a good example. Okay. Question?
Isn't it like, I think I know what I'm going to do. Isn't a radio telescope a telescope that has signals of other telescopes in there?
Say that again.
Isn't it a radio telescope a telescope that has like signals of other radio telescopes in there?
No, not really. Now they might, well, I'm trying to think how to, you might have an array of radio telescopes listening to the same thing to try to get more information from it, but they don't really listen to each other as much. Okay. Section 4 we'll probably do most of it out at the field, which is why they have pencils and the paper. Section 4 deals with the constellations and sketching the Big Dipper. We can do that out there, get that out of the way. So we'll hold that off till then. Does anybody have any more? Before I move on, I'm getting ahead of myself. Anybody have any more, for now, any more questions about the different types of telescopes? Yes, there actually is a, you've got like a, I wish I had some pictures. NASA's actually got an X-ray telescope. I believe it's called Kepler. And it specifically seeks out X-ray radiation. Well, it's
Seeks out radiation.
X-ray
radiation.
Now, like she was reminding me, in the realm of visual telescopes, there's different types. Let's see if I got some pictures here we can look at.
Yeah, there's some there.
Okay. Now this, it's kind of hard to see, but this telescope that they're looking through here, it's called a Dobsonian telescope. And the black telescope tube, right here, the actual telescope's running right here, that's what's called a Newtonian reflector. And it's called a Newtonian reflector because light comes in here, in the very back, behind the guy's backpack, there's a mirror that reflects the light back up and out where, I guess that's where the person's viewing through right there, because there's an eyepiece right here. Now, what makes it a Dobsonian telescope is there was a amateur astronomer named John Dobson. He invented this kind of inexpensive, easy to use alt-azimuth mount. Now, an alt-azimuth mount equatorial now. And what this means is, if I know where Polaris is, I can align this up with Polaris, and I can find my target, and then I only have to move one thing to keep it inside. Alt azimuth, you find your target, and you have to move it, like if it's coming up, up, and left. I mean left and right. So, well, it depends on which way you're looking actually. Because if I'm looking north, south up to my back, that's, you know, that'll be toward my left. If I'm looking south, on my right. But you have to move it up and over to track the thing. Whereas this one, you're moving one thing, which is far more steady. But all this machine work and metal is expensive. So to make inexpensive telescopes, Mr. Dobson said, you know what? We can make a plywood base and put some bearings on a reflector. And maybe when we get up to the field, I'll have a video about John that we can watch. But let's move on. That's an alt azimuth Dobsonian. And that is what's called a refractor. I should have covered that while I was up there. A refractor telescope, which this one is, has a lens pack and a long tube. It's very similar to most telescopes y'all probably used to seeing. Now, the problem with these telescopes is that, like this one right here, to buy new would be a really expensive telescope. Because to make lenses that are big requires a lot of machine work, a lot of precision. And it takes hours and hours and hours of grinding this glass that's in here. And you can imagine, you know, somebody making 20, 30 bucks an hour, if they're spending an hour, let's say it takes 8 hours to make a telescope, make one this size, then turn around and have them move and make a bigger telescope, how much more expensive that would be? But, this and the reflectors aren't the only other kind. There's a hybrid, which I actually have one. It's called the catadiopter. And it's a hybrid in that, let's see if I can find it. I don't think I've got a good picture of it in here. There's a better view of it. Okay. Well. Yeah, it's not a good view. Well, this is my telescope, and it's what they call a catadiopter. And it is a hybrid of the Newtonian telescope in that it has a lens on top here, and it also has a mirror in the bottom, and it can do real high magnification just like the Newtonian can, but it's real short because what it does is the light comes in, it bounces it back, and then bounces it back out, so that way the light path is huge. What determines your magnification in any telescope is the length of the light path from objective, which is where the light comes in, to the eyepiece. The longer this is, the more magnification. So, if you wanted to see real fine details on the moon, you either have to use a real high, a real low power, a real low focal length, which is the length of the light from the eyepiece back here, or you have to use
And we're especially going to also extend so you can go farther or closer depending on how it moves in and out.
Depending on the eyepiece. But, you know, the higher the magnification, the longer this gets. Well, Newtonians solve that by balancing the light twice. Because you can get, let's see, I keep walking back and forth. This is 1,000 millimeter focal length. That telescope that's in the picture is 2,000 millimeter focal length, which means the light actually travels 2,000 millimeters from the time it hits the front of the telescope to the time it comes out, where in this case, the camera's at. Which, given the same eyepiece, this telescope would have double the magnification of that scope, which would be great for certain objects. I mean, it's like everything else is a trade-off. Certain telescopes work better for certain things, while others don't. You know, like if you wanted to look at the moon, and you wanted to see every little minute crater, this would be great. That would be great. But if you wanted to see all the moon at one time, you need a shorter, lower magnification telescope. And when we get out and actually have different telescopes out in the field, we'll look at this more in depth. But I just wanted, we'll go on with that later. Let's see. Where are we at now? It closed. That's not good. Okay. On section 5, question A. How many of y'all know the answer to that question? Well, we'll wait till everybody gets situated. Okay. Well, I don't see any hand. Oh. Okay, that's one. That's another one. Oh, okay. I got that one twice. That's okay. Anybody else?
Venus.
Yeah.
Saturn.
There's one more that's easily seen. Right? No, Mercury's not. It's not easily seen. It can be seen, but it's not easily seen. No, it's not a planet. It's a star.
Oh.
We already had that one. That's good.
That's good.
There we go. Okay.
What were the four again?
5.
5.
Anybody want to repeat those for the people who didn't hear them?
Go ahead.
Page 6. Page 6.
6 visible.
They want you to put 5 most visible planets. But then they also gave you room for two that you
Wait, we can squeeze them in there, right behind you.
And see, I don't.
Yeah, I can see that.
That's why you need to look at that paper and see it. You gotta go by what they're doing.
Well, okay. We'll just go on to the second part of that, because you got the room for that answer.
Go by that. Go from page to page.
Okay. All right. For now, okay, on this, does anybody know which planets have phases similar to the moon? Venus does.
I'm going to take a guess, but also Mars, maybe?
No. No. I'll give you a hint, it's the one I said was hard to see, even though they say it's a 5%.
Mercury.
Yes.
Mercury. Mercury.
Now, why do they have these phases? Yeah, it's due to their position around the position in relation to us and the sun. So you're over there. Oh, okay, there we go. Do that later.
You got a question?
You got a question?
Oh, it's not really a question. We still need time to like discuss our cardboard boxes. I'm not rushing.
Okay,
at all. We
okay.
just need to yeah. Sorry.
Okay. We'll finish up as much as 5 as we can. How do the planets move across the sky?
Gravity.
Well, that's how they stick with the sun. But have y'all ever looked at and watched the planets go across the sky?
I mean, why do they move across the sky to us on Earth?
Yeah, which way do they? Because they want to know, they want you to describe how they move across the sky.
What directions they move?
That'll work too.
So you mean like in relation to Earth?
From your, like, if you were outside viewing, how do they move?
Like in those directions? Because I don't know.
Which way does the sun rise and set?
East to west. They move east to west.
Why do they move east to west?
Because of the Earth's rotation. It's the rotation because we're in position on the Earth. It's rotating. Also, I can't see the Earth.
And I guess right now, we'll, because a lot of the other stuff we'll have to do out on the field, we'll wrap up with what planet do y'all think we're going to be able to observe? What planet do you think we might be able to observe while we're out on the field? Okay. Mars is one. There's another one we should be able to observe.
Venus?
If we're lucky.
Well, maybe we see Venus
Saturn? Earth?
if we stay up there.
Uranus?
No,
Mars.
well, no, that's actually on the other sun. Jupiter's still up, so we should be able to see Jupiter. And if we're lucky, we might be able to see Saturn. And a lot of the rest of the stuff we'll have to actually do out in the field, and we'll work over out in the field. The one thing, that you need to really cover and study is section 1 about the hazards and how you need to dress when you're out doing astronomy. I know, at least at Boxwell, that was one thing they hit really heavy.
Yes.
And if y'all could have, try to work on that between now and then, definitely. But, is there any questions?
Any questions, guys, for Mr. Ben?
What kind of telescopes are like, what are all the telescopes? Names?
Well, when you say names, what do you mean?
The ones like Orion?
Oh, who makes them? Well, there's a lot of manufacturers, people who make telescopes. The most popular ones are Orion, Celestron, Ioctron, and there's a few others. Now, when you're talking about telescopes observatories, there's Vanderbilt owns Dyer Observatory in Nashville. There's an observatory on Mount Ikea. That's in Hawaii. There's a Lowell Observatory. I'll bring a flyer out about that. Any other questions?
Any more questions? All right. Well, thank you, Mr. Marion, for all you've done. Thank you very much. And we shall see.